So I'm going to speak a little bit about some work we've done to do with machine translation systems and the quality expectations that we would have based on that research. So when I'm talking about machine translation, it's usually divided into either machine translation for assimilation, which is when the raw MT is the final product. So that would be when you're using an MT system to try and get a gist of something, to maybe try and translate something from a menu to order in a restaurant, or machine translation for dissemination, which is when machine translation is an intermediate step in production. So most usually that would mean that the machine translation will be followed by post-editing. So post-editing is the term that we use only for editing of machine translation output. And post-editing is a rather contentious topic. There are different impressions about the amount of knowledge that should be expected about the quality of the machine translation system, knowledge of what sort of errors to expect from machine translation systems. Attitudes to post-editing can be quite negative, mostly because it's often imposed as a work practice as opposed to chosen by translators. There are different expectations of the amount of the quality level that can be expected of the MT or of the final translation after post-editing. And pricing is very contentious, so there's usually an assumed discount when a translator is post-editing, on average something in the region of 65% according to a research group called Common Sense Advisory in the US. And then there are different impressions of the amount of productivity that can be expected. So in general, translators are faster when they post-edit rather than when they translate from scratch. So I'm going to speak a little bit about the evolution of machine translation, a bit about neural machine translation and working with NMT, and then about MT and the artificial intelligence hype that's pushing MT into action in different use cases than we might have expected. So the first public display of machine translation was in 1954. There was a famous experiment called the Georgetown IBM experiment in Georgetown University in the US, and there was a great deal of hyperbole and a lot of newspaper articles about it. So this is a clipping from the time. There's a very interesting newsreel clip that's worth having a look at if that's of interest to you. And one of the clippings from the time says that the electric translator is the latest miracle. And we're seeing the same sort of language being used about machine translation today, to do with Google Translate making it pretty much as good as a human translator, Google's AI translation system approaching human level accuracy, and the word miracle again, witnessing the miracle of Google Translate. This all came as a result of a paper from September 2016 by researchers in Google called Bridging the Gap Between Human and Machine Translation, quite a provocative title for their paper. And that's led to other articles such as this one about the future not needing translators, tech removing language barriers, but will jobs be lost in translation, top judge predicting the end of interpreters in the UK. So we're seeing a lot of these sort of articles appearing. In March of 2018, Microsoft Research claimed that they had created a system that translated a set of news articles from Chinese to English as accurately as a human. Now there were a lot of problems with this. Their human translations that they were comparing them to weren't necessarily done by professional translators. In fact, they were done by a lot of machine translation researchers. The quality wasn't that particularly good, but it was the assessment model they used is something called direct assessment, which is used for competitive shared tasks of machine translation where different research teams are trying to produce the best system. But it's not something that's used in the translation industry. Also, there were criticisms about the fact that they were evaluating only at the segment level. So a segment would be a heading or a bullet point or a sentence. And the systems were being evaluated only at the sentence level when, of course, there are relationships between the sentences in the document that weren't being evaluated. And obviously, a machine translation system wouldn't be able to deal with those. Machine translation systems only translate at the sentence level. And actually, within that paper about human parity, towards the end of the paper, they had a list of the sort of errors that you can expect from, or at least the sort of errors that they found within their neural machine translation output. So you can see that there were quite a few incorrect words, ungrammatical words, missing words. So in fact, there were lots of errors in there. And they also used a thing called blur score. So blur score is an automatic evaluation of machine translation that is used to fine-tune a system, but really it doesn't correlate with human judgment. So in fact, when a blur score increases, it doesn't necessarily mean that the quality of the output is in any qualitative way better. So it's a little bit like the Spinal Tap amp that goes up to 11 when it doesn't actually play any louder. And just today, well actually before I come to that, there was another bit of hype that came out in June of last year about SDL cracking Russian to English neural machine translation. They didn't really release any details about that, only that they'd cracked it. And just this morning, you can see at about 2:22 a.m. today, there was this tweet from Facebook AI that they've achieved superhuman performance in English to German translation tasks. So this was part of one of these shared task competitions that I mentioned, where the different machine translation groups are trying to compete against each other. And you can see that the human quality has been surpassed by Microsoft and by Facebook. But again, these are just different sporadic human translations of single sentences done mostly by machine translation researchers. So for English-German, Facebook and Microsoft beat the human level. And for German to English, the human didn't seem to do very well at all, if you have a look at this. So this is the same crowdsourced direct assessment model. So we have 100 random people assessing the translation sentence by sentence, and via some sort of crowdsourcing platform. And these people aren't language experts, they're just random people who would like to do a micro human intelligence task for a small payment. It uses the human reference translations as a comparison, so those are also assessed in the same way. And within the paper that provided the results for this comparative shared task, they said English to German Facebook FAIR achieves superhuman translation performance. Several systems are tied with human performance. But then elsewhere in the paper they say a tie of human and machine in an evaluation of isolated segments cannot be used to draw conclusions of human parity. So they're really contradicting themselves. But essentially this idea of human parity is problematic and assumes that human translation is all of a similar qualitative level, which of course it isn't. There are some better translators, some worse translators. And this all adds to the amount of AI hype we're seeing, and hype particularly about neural machine translation. This rather unscientific graph was put together by Philip Kuhn. He's a researcher and a professor that was in Edinburgh and now is in Johns Hopkins University in the US. And he reckons that this is the first time that the hype about neural machine translation, or about machine translation in general, has surpassed that of the Georgetown experiment in the mid-50s. Whereas he sees the reality is that we're seeing incremental increases in quality of machine translation output. So if we look back at the history of machine translation, the first impetus for this was a memorandum sent about within UNESCO from Warren Weaver in 1949. And he said that when I look at an article in Russian, I say that this is really written in English, but it has been coded in some strange symbols. I will now proceed to decode. And his suggestion was that that it would be possible to build machine translation systems that would use the coding and decoding information, or the coding and decoding computers that were built in Bletchley Park and elsewhere in the Second World War. And rather than translating word for word, he reckoned that it might be possible to take note of the context either side before and after each word. But essentially he believed in translation universals, that or language universals, that there'd be certain commonalities between all languages. So as a result of that, the first full-time permanent employee in machine translation, a postdoc researcher called Yehoshua Bar Hillel, was employed in MIT in the US in 1951. And Bar Hillel was a mathematician and philosopher. He had the first machine translation conference that he started in 1952. And there was a lot of effort and money put into machine translation research in the coming years. As part of the IBM Georgetown experiment, they proclaimed that they'd be able to translate all of the output of the USSR within about 5 years. But when that didn't come to pass, there were certain criticisms started to come to light about machine translation. And also Bar Hillel saw the limitations to machine translation. But I'll come back to that in a moment. So the Georgetown IBM experiment in 1954 involved 12 machines, collectively known as the IBM 701, and it had 250 dictionary lexical items and 6 rules. The IBM founder, Thomas Watson, said, "I see this as an instrument that will be helpful in working out the problems of world peace. We must do everything possible to get the people of the world to understand each other as quickly as possible." But there are reasons why translation is hard for computers. So computers require exact instructions. They're not very good with vaguely specified tasks. So common sense reasoning would be problematic. So this headline about Michael Foot, the former Labour leader in the UK, "Foot heads arms body," would be something that would be problematic for a computer. "Our Jimmy has grown another foot." Trying to determine one solution from a number of potential choices. So the example here is gas pump prices rose last time oil stocks fell. There are a number of different ways that this could be translated, and computers have problems with trying to decide on one of those. So Bar Hillel in 1959 identified what he called the semantic bottleneck, and this was mostly to do with ambiguity. So he gave the example of these sentences: "Little John was looking for his toy box. Finally he found it. The box was in the pen. John was happy." So trying to disambiguate the word pen calls for real-world knowledge, and that's difficult to code in MT, and therefore he concluded that fully automatic, high-quality machine translation wasn't possible. So when we're trying to create systems for machine translation, there are 2 dominant paradigms. The early paradigm was this rule-based MT paradigm, where it's a case of trying to encode the linguistic knowledge, and later data-driven MT became popular. Early on in the 1980s, example-based MT was used for English-Japanese systems, and then statistical MT, where it was just a case of trying to gather as much bilingual aligned data as possible, source and target texts that were aligned sentence by sentence to try and find the most statistically likely translation. And neural MT is also a statistical or data-driven paradigm. There have been some efforts to hybridize these systems, and there still are to a certain extent at present. So the first strategy, the rule-based strategy, is to capture all the knowledge necessary to understand a source language text, and then to map those linguistic elements of that text onto the target language elements. Then to work out some way of getting the machine to use that knowledge to get from source to target. So it's closely linked to linguistics. It's often source and target language specific. It worked quite well for languages that are closely related. So this Apertium system is still used commercially for translations from Spanish to Catalan and vice versa. Strategy number 2 is to try to copy human translators, to find source text and target text produced by humans, often based on translation memories, if you're familiar with those, to work out how the phrases correspond between the two, and then use these correspondences to create a probabilistic model of translation. And when the first paper was sent for review in 1988 about this, there were complaints that raw computing power would never replace human translators, but nevertheless this became the dominant paradigm from about 1990 up until about 2015 or so. So the state of the art now for machine translation, this is going back to these competitive shared tasks year on year. And if we look at the automatic evaluation of statistical output for English to German, for news translation, year on year, we can see there's not a great deal of improvement for either phrase-based or syntax-based statistical machine translation. But once neural machine translation was introduced in 2016, we could see a jump in the quality of output, and that was replicated the following year. So whereas SMT, statistical machine translation, involved predicting the most likely translation by building a translation model. So the translation model was based on the parallel source and target language data. The translation model would produce a number of different potential solutions or potential translations, and these were put together in what was called a phrase table. Then the language model, which was trained on monolingual target text data, would be used to try and choose one of the choices from the phrase tables, try and decide what's the most statistically likely segment to see in the target text. And then there were many small subcomponents that were tuned separately for the language pairs to try and tweak the output to improve it somewhat. So for NMT, it usually involves building and training a single large neural network that reads a sentence and outputs a correct translation. However, this new Facebook system that they just announced this morning is actually using the translation model and language model, that sort of technology from the SMT era, but up until now systems haven't used that. It's been a single large neural network. It uses a recurrent neural network to deal with variable segment length, because at its very basis, neural MT can't deal with variable segment length or sentence length. And it predicts a target word based on the context associated. Oh, has something gone off? On the context associated with the source and the previously generated target words. There we go. Is that working better? Ah, yeah, that's working okay. Yeah, this just dropped down. Oh, right. Can everyone hear me okay? Yeah, good, good. Thank you. In fact, it was probably too loud anyway, wasn't it? So then it also has a small neural network called an attention mechanism that analyzes the context for every source word. So what the attention mechanism does is that it creates a sort of word cloud of likely collocates for each word, and each of these has a connection to the likely collocates. These connections are either strengthened or weakened depending on the training data and depending on the words that have been produced so far in the sentence. So where there's a strong connection, that will be the next word produced. So quite early on in a paper by Graham Neubig and others in Carnegie Mellon in the US, they found that the main strength of neural machine translation was grammatical improvements, but there was a possible degradation in lexical transfer. So some further problems: it's computationally expensive, it's expensive power-wise, the graphical processing units to be used are very expensive. Networks have a fixed vocabulary, so there's a poor translation of rare and unknown words. So the way to get around this is by breaking words down into subword chunks, which aren't necessarily linguistically motivated. And that's a process called byte pair encoding. There's poor adaptation to a field or a specific domain. So and because of the amount of data required, engines are usually general purpose engines, as opposed to ones that are specifically for life sciences or for certain technical uses. There are problems with long sentences. We usually, if the source text is over 40 words long, if we're talking about English, then there'll be problems with the output. Models are trained on bilingual data up till now, so to use the monolingual data that was gathered in the target texts in the statistical machine translation era, the process has been to back translate using a machine translation system, which obviously includes errors, but that's all fed in to the training data. And it's difficult to incorporate terminology in any sort of consistent way, and we've got a couple of people working on that in DCU at the moment. Also, Google produced this zero-shot machine translation system, where the system was trained on English to Japanese and vice versa data, and English to Korean and Korean to English data. And each of these language pairs were labeled, and they were able to translate using this system from Japanese to Korean and Korean to Japanese, even though there hadn't been any aligned data in those language pairs. So they tried to explain this after the fact by suggesting maybe there was an interlingua created within the system, but in actual fact they don't really know why this worked. And they've carried on this research by building systems that are multilingual. So now there are systems that will translate multiples of languages, and the text from each of the languages is labeled. And it means that for the languages for which there are a great deal of data, they're finding that the quality isn't quite as good as a language-specific system or a language pair-specific system. But for the language pairs for which there is little data, that those are raised slightly. So I want to tell you a little bit about a comparative evaluation that we did as part of a European-funded project called TREMOOC. The idea of this project was to build a replicable method of translating massive open online courses. So we were trying to translate mostly subtitled courses, but there was also some user-generated material that was in there as well, some blog posts. So we had 4 data sets of 250 sentences that were from real English language massive open online course data translated from English into German, Greek, Portuguese and Russian. And they were on the topics of business, medical training, physics and advertising. So we had phrase-based statistical machine translation and neural machine translation, and the output was mixed and randomized. We had 2 to 4 professional translators as our evaluators, and we had our MT engines trained on the same data. So this was the openly available corpora in these language pairs, and then some specific educational data. We used a system called transfer learning for neural machine translation, where it was trained up to a certain point on the general data, and then we swapped in the genre-specific data. And we had a few different types of evaluations that we did. So one was a comparative ranking of 100 randomized translations. We had the participants post-edit, and we looked at temporal effort, so the amount of time spent post-editing measured in words per second for each segment. The technical effort, so the literal number of edits they made. We considered trying to add cognitive effort, but we didn't get round to that. We rated fluency and adequacy, and did some simple error annotation of morphology errors, word order, omission, mistranslation, and addition errors. So we ranked the output side by side. There was a preference for neural machine translation output for all language pairs, for all text types, even for different segment lengths. We can see it was particularly marked for German. The ratings for fluency were higher for all language pairs. So we can see that those assigned 3 to 4 fluency scores of near native or native were higher for all of the 4 language pairs. But when we look at adequacy, trying to answer the question, how much of the meaning expressed in the source fragment appears in the translation fragment, in that case, our evaluators considered that the statistical output was more adequate for German, and where there was an improvement seen for neural machine translation output, it wasn't really to a notable extent. So some examples. For the source text, I'm just making sure that I understand this correctly. In the SMT output, it used so in Portuguese, meaning just, but also alone or lonely. So the meaning being, I'm lonely if I understand this correctly. The NMT got it correct. For the source text, would you send just 10 materials that are the most suitable? In the SMT output, it left out the infinitive verb, so would you just the 10 materials? For the NMT output, it uses the imperative, so schicken Sie einfach 10 Materialien. And even though it used the imperative, our evaluators considered that this was correct because it uses the capital polite Z. It's about copy-paste from PDF to WikiCard. These are the sort of mistranslations we started to see in NMT output, where it used the word for toothpaste rather than copy and paste. And for the source text, was webinar live today, the NMT and SMT output was quite wrong in both cases. And for this longer segment, we begin our exploration today by looking at a particular ad that appeared in American magazines in recent years. The SMT output contains word order and verb errors, but the NMT is quite fluent, but our evaluators considered that it wasn't that accurate because they were unhappy with the choice of the word Forschung. So they felt that Erforschung was a better translation for exploration, and that Forschung meant research. And while that's arguable, these are the sort of things, the sort of errors or changes that NMT output might make. And if you consider that that's an error, then that would be very difficult to spot, especially because in other ways that segment is quite fluent. Then in terms of temporal efforts, the amount of time spent post-editing. So our expectation based on the first evaluations was that post-editing would be much faster when post-editing neural machine translation, but in fact it was only very slightly faster in words per second. And that became more curious when we looked at the number of segments that were left unchanged. So quite a lot of segments were left unchanged for each language pair. So that would suggest that when there were changes to be made in post-editing, then that those actually took longer than SMT post-editing. Looking at the number of keystrokes per segment, there were fewer keystrokes required for NMT post-editing, so that's as we might have expected, not always by a great deal. Now there's a lot of data on this slide, so it's a little bit hard to see, but segments with no issues, there are far more segments for each language pair with no issues in NMT output. But if we start to look into the data in more detail, we can see that for Greek statistical machine translation, there were fewer omission, addition, and mistranslation errors. There were fewer omission errors in Portuguese SMT and fewer mistranslation errors in Russian SMT. So while the headline scores point towards NMT being of better quality, there are still some problems in the output. So we could say overall that fluency is improved, that word order errors are fewer using NMT. There were fewer sentences that required editing. It produced fewer morphological errors. That there was no clear improvement for omission or mistranslations, and there was no great improvement in post-editing throughput, and our evaluator said that the errors were more difficult to spot. And similarly, some work by Masaru Yamada in Kansai University, he found that his students weren't very good at spotting the sort of mistranslations that would be in NMT output. So following on from this, we put out a call for papers for a special issue of Machine Translation Journal to see if our findings would be common to other studies. And of the 8 papers that were published in June of this year, we found little or no productivity gain in lots of different domains and language pairs: English-Spanish, English-German, English-Dutch, with the exception being English-Chinese, which did produce faster translations or improved throughput. The productivity gains that there were outside of Chinese were if there were productivity gains, they were minor and weren't statistically significant. Often a disimprovement for longer sentences. But NMT was always rated highly for adequacy, fluency, automatic evaluation. The technical efforts, the number of keystrokes, was always fewer. And one quote is that while there are fewer errors in NMT than in SMT, they could be harder to detect and solve. For interactive systems using MT as auto-suggest, again, we found that, our contributors found that NMT wasn't necessarily faster, with the caveat that there were a small number of participants and that the participants preferred working with NMT output. So here's an example of the sort of errors that we found or we might find in NMT output. When "My Dear Compatriots" was translated as "My Fellow Americans" when Emmanuel Macron was elected in France, based on the amount of American training data. Some other strange things have cropped up. So when translating from Somali to English and inserting ag a number of times, we have this output here. And this is probably because in a lot of the training data for African languages is missionary data. Eva van Massenhoven, one of my colleagues who's just completing her PhD, has found examples of this. This is the sort of ambiguity that Yehoshua Bar Hillel was talking about when somebody was shooting bullets and we saw her duck, and in the French translation uses the animal duck. And the translation of the source text "I trained" was translated as "it rained." So this probably is down to the byte pair encoding, where words are broken down into chunks that I mentioned earlier. And while that usually works well to produce compound words and to produce words with prefixes or suffixes that mightn't be in the training data, there can be problems, as you can see. I am smart was translated into French using the male adjective, but once you add I am beautiful but, then the adjective changes to female. So looking at how good NMT could possibly be, I would consider that as limited by real-world knowledge. A quote from a paper that I produced in 2017 is that human communication interprets cultural and contextual information to reach mutual understanding. And that's something we were really talking about earlier, I think, with Michael, the fact that real-world knowledge is necessary to come to a mutual understanding. It's limited by context, so there are some efforts to translate at the document level, but at the moment, MT translates at the segment level. It's limited by the training data, which includes good translations, bad translations, medium translations. It includes automatic back translation using MT. It includes MT itself, MT output. It's limited by linguistic expectations. So, for example, in German, there is expectations of more explicitation than would be required in English. So, for example, here, the source text, visual observation, was translated as visuelle Beobachtung, whereas the human translator would made this more explicit, translating it as durch Sichtprüfung festgestellten Ablagerungen. So in that way, the meaning of the target language is really reflecting the meaning of the source language. So in looking back at what Catford wrote in 1965, he says, in normal translation, the target language text has a target language meaning. That is to say, the values of target language items are entirely those set up by formal and contextual relations in the target language itself. It is possible to carry out an operation in which the target language text, or rather parts of the target language text, do have values set up in the source language. In other words, have source language meanings, and we call this process transference, and that sounds like more what machine translation does rather than translation per se, but because it's called machine translation, that name at this stage will probably stick. So another concern to do with machine translation is to do with data dispossession. So it's a problem that's rife within the digital domain and is a problem for many knowledge workers when the metadata is often removed from big data. But looking at the Berne Convention and the various other conventions to do with copyright, there could be various claims of copyright for translated work. So the claim by a translator for a translated text is it sort of comes, it's subsidiary to the copyright claim of the original author of the source text. But even the idea of originality is rather difficult to define, and has been difficult. It's been problematic in court. But also there's a translation right that accrues to a translator. So if the work is to be reused, so for example, if I wrote a book and that book was translated by Akiko, then I couldn't ask someone to create a further translation based on Akiko's translation without her permission or without paying her royalties. Then within the EU database directive states that a database such as a translation memory, that there should be some sort of rights based on if substantial effort has been put into managing and creating that database. But all of these sort of copyrights are currently ignored within the translation industry. The precedent is that translation memories are inevitably handed over. But the claim that the Bird and Bird report that was commissioned by the European Commission, written by Troussel and de Bush in 2014, would make is that depending on the type of text and depending on the type of translation, there might be further claims of copyright that could be put forward by translators. And if there were conflicting copyrights, then that would be problematic for reuse of that data for machine translation, because machine translation it relies on human translation for its data, for its training data, but also for its validation. The whole the idea that machine translation is in any way correct or is likely to be correct is because it's based on human translation data, with the assumption underlying that human translation data is good. But the AI hype is starting to change attitudes to machine translation aside from the increases in quality. If we look at the number of searches on Google, or the appearances in data that Google has gathered of the word algorithm over time, we can see it's gaining ground rapidly. And while there's been some criticism from the likes of the master algorithm or weapons of math destruction, where Cathy O'Neill has written about bias for artificial intelligence, the combination of the hype about MT and the increases in quality mean that more and more language service providers are offering some sort of MT or post-edited MT product. And especially this graph from Common Sense Advisory from 2016 shows that within the last year of this, before this survey, that over 80% of small, medium and large language service providers in Europe said that they were offering some sort of post-edited MT product. So the conventional wisdom for using MT is that the degree of human involvement required or warranted in a particular translation scenario will depend on the purpose, value and shelf life of the content. But we're finding that pressure on cost and MT hype is pushing MT into action in use cases that weren't previously considered suitable. So there was a paper by Dag Schmidtke from Microsoft where he talked about how they're using MT and post-edited MT for Microsoft Online support and documentation. We've got an experiment ongoing in our university where they're using MT for user interface translation for Microsoft Office products. We've done experiments on neural post-editing where we're trying to use neural networks to automate the step from SMT output to post-edited SMT output. It doesn't work quite so well for NMT because really we're trying to do the same process twice in that case. There's been experiments to do with MT for subtitling. There was a project called SUMAT that was looking into that, and a PhD by Carla Ortiz-Boyce. But increasingly, especially in Asia, we're finding that subtitlers are being asked to do subtitle editing jobs rather than translating and subtitling from scratch. And that's quite problematic because the languages for which they're being asked to translate aren't necessarily ones that are well served by MT. And there are a couple of companies now that have created interfaces that work with MT specifically for subtitling. There's been work on patent translation for MT, using it for e-discovery, trying to decide on what are the appropriate documents to translate for a court case. And we've done some experiments on MT for literary texts, not so much to try and translate books to be published, but more to test how far MT has come. And I'll be giving a talk about that on Friday afternoon. So this is in the context of massive digital data growth, where 143 billion words were translated using Google Translate per day in 2016. It's more at this stage. So there should be a requirement for lots of human translation and lots of machine translation. So just to finish up, we're trying to look at how machine translation can be incorporated in a sustainable and ethical way within translation workflows, to try and encourage longer-term thinking of value. So rather than just trying to impose machine translation as a short-term cost-cutting measure, to try and value longer-term thinking and to build up relationships with translators that would involve trust rather than just having some sort of distributed ledgers. Looking at professionalization and how to define the liminal edges of the translation industry, to do with copyright, as I mentioned. And I'll be talking about translation copyright as well on Friday. So is there a balanced approach? Is there an argument for a translation commons where data can be shared to the benefit of all? But not just translation data, but personal data, which could be of value as well. Or is the current trajectory perfectly sustainable? And we have a workshop about this at a conference in Dublin on August 20th, but also we have a call for papers out for an issue of Translation Spaces trying to look at these sort of problems. But in summary, NMT has improved MT quality for languages for which there is sufficient training data. post-editing throughput has mostly not improved as might have been expected. We want to do a study next to try and look into why this might be. So we're going to start an eye tracking study once I get back to Dublin and try and identify what sort of errors are causing these delays. Or is it that translators need to look more times between the source and target text to identify whether there are errors at all? MT engineers are mostly concerned with MT for assimilation, so gist translation. So not that much effort is being put into interaction with translators. The media discourse about artificial intelligence and MT, it worries translators, but also it raises unrealistic expectations among translation buyers, among clients. And if MT is to be added to translation workflows, it should be in discussion with translators in a fair and ethical way. But that does mean that there's pressure on translators to continually update their technical knowledge, to be experts and to be able to advise on how to incorporate MT and what text it's appropriate to use MT for, where it's not appropriate. And that's it. Thank you very much for your time. So if you have any questions, please let me know.
So thank you very much, Dr. Moorkens, for your fascinating lecture. So I would like to open the floor for the questions and answers session. Comments, questions?
Have you ever looked at word use like frequency compared with either of the machine translations versus humans? Are there certain words that we've, I guess, fed to the machines or that are coming up more frequently in machine learning than they would in human translation? Or grade?
We haven't really looked into that or found whether there's different word frequencies. There's an argument that the language that's created by MT systems is to an extent frozen in aspect, that it's based on historical data and could never keep up with contemporary language use, because it's based on historical data. So for example, for English to Chinese, as I mentioned yesterday, there's a lot of the training data that's used is from broadcasts from 1946 to 1991. And a lot of the training data that's used for European languages comes from the European Commission. So as you might expect, it's quite formal. It uses the sort of European sociolect, what you might, the words are used in a different way. So there probably are different frequencies, and there has been some work on translation ease as it comes through machine translation, as the differences in the language generally, not so much word frequency, but the sort of patterns you might see. And there was a paper from just about a month ago by Antonio Toral in the Netherlands about what he called post-edit ease. So certain patterns, rather than specific word frequencies, that he felt were common even in post-edited output, that these patterns weren't removed. They tended to shine through in the post-edited output. And that's probably because post-editors are encouraged to include as much as possible of the raw MT output in their final output. I don't know if that answers your question. But thanks. There are two questions here.
Because it is sentence-based,
Mm-hmm.
how does the translation work from Chinese to English, let's say, where the past tense is easily marked in English with an ed or something similar, and in Chinese it doesn't even exist?
Well, the systems aren't trying to use any sort of linguistic rules, so it's only based on using its training data. So if the past is translated as as present, then that's what the training data will tell it to do. But because I don't speak Chinese languages, I wouldn't be a good judge of how good or bad the output is. But I'm told that the output is of a reasonably good quality. But you know, that's as good as I can answer that question. I'm sorry. There's one question in the back.
There's a lot of money in developing these systems, and they're hoping that it's going to go somewhere. I'm wondering, how involved are linguists in the process of developing this? Or are they all excluded?
Linguists are not very involved at all. So because of the cost barrier, it means that the sort of teams that can develop these systems are from the big tech companies, from Google, from Facebook. And while the teams are multilingual, they generally are computer scientists rather than engineers. And there was an argument between one of Microsoft's engineers who is a trained linguist but has been working as a computer scientist for years, claiming that he sort of represents the linguist community. And one of my colleagues who said that, well, if you're not working as a linguist, then you're not, you know. But in general, the big tech companies they'd be working with almost all computer scientists. The university research teams would be a bit more mixed, but still those are mostly computer scientists. And I talked about those competitive shared tasks. It used to be that in the list of the sort of winners and losers, the leaderboard, we would see lots of names of universities. Increasingly, we're seeing industry research teams and the ones with the most money coming towards the top.
Thanks for your talk. How can we facilitate like the sharing between linguists and computer scientists? Like, how can we find a middle ground? So if you're a computer scientist, how can you learn enough to do some of this machine translation? Or if you're a linguist, how can you learn enough computing, enough algorithms to be able to contribute in some way without being, you know, a mix of both?
What happened with statistical machine translation was that at a certain point, the development plateaued, and that was when they needed input from linguists. The expectation from the outset for statistical machine translation in the first papers that were written by Peter Brown and his colleagues from IBM was that, you know, we're starting things off and now the linguists will take over. But the hubris of the NMT developers doesn't necessarily lend itself to having linguists so involved at this stage. The argument that we're trying to put forward at the sort of Fair MT workshop and others is that, you know, there should be more of a conversation within both, or between both. As for translators, I don't see that it's necessarily beneficial to learn how the algorithms work. It might be better because, you know, I think understanding expectations of where it's appropriate to use it and what the output might look like. But, you know, if you've got people who have been programming for 20 years, you're unlikely in, you know, a short period of time to try and beat them at their own game. So it would seem that to me anyway, that it makes more sense to try and accentuate where linguists have more knowledge about language. I think in general there's a move for people working on machine learning and artificial intelligence tasks to think about the end users and how their technology will be deployed. So at the moment, for example, there were people who went on strike and left Google in the last couple of months because they had a load of demands for Google, and one of them was that people working on tech should know what the final use of that tech would be. and at the moment it's opaque to them. And there's a book by Shoshana Zuboff that came out in the last couple of months called The Age of Surveillance Capitalism, where she reiterates a quote from the 80s from a retired professor at the time whose name I can't recall, but basically that that people working on technology should try and think about whether they're happy or not with the end use of that technology, and they should never work on something without making that consideration. So while we're trying to promote that amongst machine translation researchers, I don't know necessarily if that'll be taken on, because at the moment their motivation is to have incremental increases in their output quality, using automatic metrics, and to publish papers. And the tendency is to sit behind their machines and not really engage with translators. And rather paradoxically, that was what got me a job at one stage, to be the go-between in a computer science department for machine translation, and to try and use humans to evaluate. But I find that the people at higher levels, very much want to try and, broach the gap between translators and machine translation developers. So the professor who leads the group in our university, for example, he prefers to speak at translator conferences now rather than machine translation conferences, to try and have more of a conversation. So certainly from some people the willingness is there.
Just on that last, just very quick, there's a lovely little conference working group called CompuTel, which is a opportunity for linguists to come together with technologists and talk about sharing knowledge. It's only a year or two. It's worth checking out. CompuTel.
And where is that?
It moves around.
Okay.
It was co-located with the LD&C conference in Hawaii this year.
CompuTel.
Send some information out.
Cool, thank you.
Thanks. I work for a company that makes data for machine translation, and I was wondering, is there like a tangible effect from like training data that's crowdsourced and produced by non-professional translators, and training data that's produced by professional translators? Like, could you quantify that effect in the output of the entry?
Right now, no. And that's a research question that's certainly a hot topic at the moment. And DeepL, for example, are very assiduous about trying to have clean data, and they claim that that's the basis for their quality generally being considered better than the likes of Google Translate. And they do use crawled data from the internet, but they claim that they're also quite careful with how they use that. What was I going to add? Also, as I mentioned to Akiko yesterday, Google's localization team don't use Google Translate. They don't think that the quality is good enough and that the data has been carefully curated. So they use purpose-built systems from a campus company in my university and pay list price for it. So that might point towards not being that careful, being with what data you use for training, that might be problematic. The claim in that the Facebook paper that came out this week is also that they were very careful with their data, but they used automatic means to try and trim the crawled data. So they tried to look for equivalent sentence lengths, for example, and if there was a big disparity between sentence lengths, then they removed that. So they used a lot of sort of common alignment techniques, but no one has managed to quantify exactly what difference it makes with different types of training data or qualities of it. It's really just about amounts at present, and the idea is mostly that more is better.
Well, do you have anything else apart from Google Translate as MT?
Well, it depends on the language pairs, but there are lots of different MT producers. So there are those sort of online producers like Google or Facebook or DeepL or Amazon, but also there are lots of smaller MT companies. They don't necessarily have publicly available online MT, but if you provide them with data, then they'll create bespoke systems for you. And some of the big providers are starting to do that as well. So, for example, Microsoft have their Bing online translator, but they create bespoke systems as of, I think, August of last year. If you provide them with training data, they'll have a purpose-built system that they can create for you, depending on the amount of training data you have and if it's sufficient.